So on this one, they're going to give us like fractions, which means that the denominators are all going to be the same for this one, which means we don't have to really look at these or make them the same size pieces. They already are for us. For example, this first one, number 1, it says it's 1/2 plus 1/2. So if we look at these in two separate, sorry, these aren't perfect, but if I divide these in half, and then I said I got this half and this half. See, if I took a third box and divided it in half, and then I can move this one into it, and then this one into this piece right here, and I would have a full piece. Does that kind of make sense right there? Maybe I could show that a little different. So if I add these two, then I should get something equal to something like this. There we go. So when we add these two, we should get 1. Now again, this is made possible because we have the same size pieces. All right. Otherwise, we'd have to look at this very different, or would have to divide what we have into equal size pieces. All right. Number 2 is the same way, except for we got a mixed number on that second one. Yeah. So let's set it up though. So if I had the 1/2 right here, but then with this other one, I've got 2. And then another 1/2. So again, I've got these 2, and then this half. Well, if I just took this half and moved it over into this half, then we can see we'd have 3 full parts, pieces, wholes, whatever you want to call them. You can even say pans if you wanted to. Why, like brownies or cake. Not everyone needs these types of models, but hopefully they help. Okay. So on these ones, we're going to add or subtract, and of course we'll simplify. So here's another way we can look at this, is we got these fifths right here. So I've got fifths. I'm just going to label these. In any case, whatever it is, fifths. I want to say there's an F there, but whatever. I think there is. Fifths. And, well, how many of these do we have? Well, to start, we've got 2. And then I'm going to take that and I'm going to add this one right here, right? So I had 2 fifths. And then I'm adding 1 fifth. So when I add these together, I still have fifths. But now I've got 2 plus 1, which would give me 3 fifths. Okay, now, of course, we wouldn't write it like this. To finish this off, we would write it as 3 fifths.
So they're not doing anything to the denominator?
The next part, they won't be the same denominators, but for now, this is kind of how this works. Now, I don't know if it helps to see it like this. It may help us with the language of what is happening, though, okay? As long as we have the same thing, fifths, we can just add however many of those we have. All right, let's use models on this one. So we got tenths. So I'm going to show the 3 tenths first. Okay, so this would be 3 out of 10. Now those aren't exactly equal sized pieces, but let's pretend that I drew that perfectly. And then in addition to that, I'm going to add 5 more tenths. All right, so this will be 5 of the tenths. There we go. So when I add these, and we can show it like this, so I need another bar. I can tack on the 5 and then the 3. All right, so let's show the 5 first. I'm sorry, let's show the 3 first because that's to the left there. And actually, I'll make that a different color now. So these ones will be purple. We got the 3. And then we got the 5. So 1, 2, 3, 4, 5. And now we just got to figure out how much of this thing is filled up. So again, we're dealing with just tenths here. But how many tenths do we have? We got the 3 and then the 5, 8 tenths. Now, of course, this could be split up, right? So I could take this and I could say that this would be 1 part, this would be 2, 3, 4, and 5. And then we've got 4 out of 5 pieces filled in there. And yes, we could look at this kind of like we did last time, right? It's like we took the 8 and divided it by 2, and the 10 divided by 2 as well. So let's look at this strictly algebraically or mathematically. So I've got the same amount of sevenths on this, and I am adding, but I'm taking this 6 and I'm adding it to this 4. So I've got just sevenths. I've just got to add the 6 and the 4 together, which would be 10 sevenths. See, and that's the nice thing about having common denominators is we're just adding sevenths. Now this is kind of like number 3 that we did. It's just shown differently. We're adding sevenths. There's on this. So mixed numbers on this one, right? 10 divided by 7. 7 goes into 10 one time. Subtract the 7, we got 3. So it's 1 with a remainder of 3 sevenths as a mixed number. So let's use the models on this one. Just we'll hope that it kind of solidifies. So let's look at the 4 and 1/8, right? So I've got 4 full boxes on this. And yeah, they're supposed to be the same size. And then in addition to that, we've got another box. But it'll be split up into eighths and we'll have one of them filled up. And there we go. Well, on the other hand, we also have, and we're adding this to the 3 and 5/8. So I got 3 full boxes again, and then 5/8. There we go. So when we combine these, or add them, right, we can see that we'd have these 4 full and these 3 full boxes. And then we should have another box split up into eighths. All right, so let's fill this thing out and see what we get. So I got 1 from the red, and then I got 5 from the 8. So 1, 2, 3, 4, 5. All right, so that gives us a total of, again, we got these 7. Try that again. Can't be having technical difficulties this early. So that gave us 7. And then, in addition to that, we got this box down here, right? And if we count those, 1, 2, 3, 4, 5, 6, and that will split up into eighths. About 6/8 we can simplify. Once again, if we break that down, just the box, we can break it up into 2 parts each. And then we can see that that would be 7, and then it would be 3 out of 4 parts that are filled. And there's the answer. Now this takes a little bit of time, but hopefully again it helps you understand what is happening. So on this one, here's what I would do is I would change this into improper fractions. Okay, so we can do that. Again, this will tell us how many fifths exactly that we have. So I got my 1 times the 5 plus 3 gives me 8 fifths. And I got 7 times 5, 35 plus 4, 39 fifths. And I'm adding these together. So, from here, yeah, Again, I'm dealing with just fifths, but now I've got this 8 plus the 39, which would give me 47 fifths. Now again, this is the improper fraction, so to change it back, I got 47 divided by 5, which would be 9. So subtracting, I got 2 remaining. So my final answer, 9 and 2 remaining out of 5. All right, so mixed numbers, as it turns out, are actually separated as well. So, for example, 2 and 1/6 is the same as 2 plus 1/6, like this. And then 3 and 5/6 is the same as 3 plus 5/6. Now we're adding these two together, right? So what I could do is I could rearrange this using the commutative property of addition. And I could move the 2 and the 3 next to each other. And then I could move the fractions next to each other, like this. So when I combine these, I've got 5. And when I combine these, I've got 1 and 5 would give me 6 of the sixths.
This would be 6.
Yep, so we end up with 5 plus 1, which is just a straight 6. All right, so let's look. So again, we're dealing with ninths. So in any case, and yeah, we are dealing with subtraction now as well, right? So I got 7 minus the 2 ninths, which would be 5 ninths. Now, it's good. I saw some of you guys look to simplify this. But the 9, if we split it up, right, would have 5 over 3 times 3, and there's no common factors there to cancel out. So this is our final answer. Right, you got the 2/8 from the 7 minus 5 eighths, which is 2/8. But again, if we break the 8 up into 4 and 2, and we could take that a little bit farther, but then we can see that the 2's cancel. Now we can't forget that the identity property, we can multiply that by 1, which would give us the 1/4. So if you cancel everything in either the numerator or denominator, just know you have a 1 there. It's a phantom 1. We don't have to show that. But if we do show it, that's fine as well. So let's do this one. For this one, I'm going to change this into an improper fraction. So I've got 5 times 6, 30, plus 5. I got 35 sixths. And then I've got 3 times 6, which is 18, plus 1, 19 sixths. And we're subtracting this. So this comes out to be 6, and we're subtracting. But I've got that 35 minus the 19. So that would give me 35 minus 19, 16? 16 sixths. But these can be simplified. We can see they're both even, so we can divide them both by 2. And we got 8 thirds. But, again, on the homework, they wanted mixed numbers for these. So we'll change these. 8 divided by 3 twice, so 6 with 2 remaining. So my final answer, 2, and a remainder of 2 out of 3. So on this one, let's work with the mixed numbers. So this would be like saying I've got 4, and then I've also, in addition to that, have this 4th. Now, over here we're subtracting 2, but since we're subtracting the 2 and the 3/4, I've got to subtract the 3/4 as well. Now this is where we kind of run into problems a little bit.
Oh, we got to subtract it from the 2?
Yeah. Because since we're subtracting the 2 and 3/4, we got to subtract the 2 and we got to subtract the 3/4. So again, this is where people get kind of mixed up with this stuff. We can move this stuff closer together though, so I can show that I got 4 minus 2. But the problem is when I get 1/4 minus 3/4, I don't have enough fourths to take away the 3/4. Which means that from the 4, I'm going to have to split this up. See, I'm kind of doing this to show you guys the inconvenience here, right? So I have the 3 plus 1, but I'm going to take this 1 and move it over with the fourths, which would have made it 4/4. So when I add those two together, I actually get 5/4, and now I have enough to take away from the fourths. And that would be 2/4. But now I've got 3 minus 2, which is 1. 1 and 2/4 really should end up being 1 1/2. Now, of course, he didn't have to use that method, but again, I kind of did that on purpose to show you guys the inconvenience of this method, especially with subtraction. If we're just adding, then hopefully we're in good shape there, as long as both of the mixed numbers are positive. But in this case, where we're subtracting, but we didn't have enough fourths, we've got to convert that. Kind of like borrowing when we subtract.
So when we subtract
Whole
it, it's
numbers.
easier to go with.
So yep, I recommend improper fractions for
Subtract.
any subtraction. Yeah. All right, well then let's use improper fractions on this one as well. Now again, hopefully you guys notice, right, we got the 5/12 and then minus the 7/12. We still don't have enough 12ths to take away, unless we went into the negatives, which we don't want to do yet. So we'll just change these into improper fractions. 5 times 12 is 60, plus 5, I got 65/12 here. And then I'm going to have 12ths here as well, but 3 times 12 is 36, plus 7, 43/12. And I'm subtracting this. So I still got my 12ths and subtraction, but I've got 65 minus the 43, which in 12ths would be, I got 22 on that, which we can simplify both of these by dividing both of them by 2. So now we get 11/6. So again, in mixed number, 11 divided by 6, 6 can go into 11 once, minus the 6, and I'm left with 5. So a remainder of 5, I got 1 with the remainder of 5 of the sixths.